How can we turn the table on attackers and exploit their attacks to our defensive advantage? Attacks often involve multiple probing attempts, with most of them failing and resulting in exceptions within the target. Our research investigates how exceptions could be turned into canaries for the trial and error stages of attacks. We also address the lack of attack-aware defenses available to web application developers. The experiment consists of an instrumented environment in which we collect exceptions emerging from a test application under attack. Initial test cases suggest that a canary might require two stages. The first one to observe suspicious exception patterns, and the second one to analyze the payload of the exceptions. Work in progress also looks into the configuration of libraries from which exceptions can result, and how they impact the effectivity of the approach. Have a virtual stop by our poster and learn more about our research on angry birding.
Hi, I'm Jae Baek from Arizona State University. As you know, Android apps are widely used and enjoyed by the users, but the permissions that users grant to these apps are well known to be abused by attackers for malicious purposes. To address this problem, we have developed DiperDroid, a security framework that dynamically restricts the permissions without needing root access to the devices and modifications to the actual code of apps. In a preliminary evaluation, we have successfully prevented a self-developed malicious app from abusing permissions, like the unintended leak of phone contacts to a remote server. Furthermore, we are currently analyzing a series of malicious apps to better evaluate the effectiveness of our approach. I hope to see you by our poster stand during the conference. Thanks for listening.
Federated learning, a type of machine learning, is used almost everywhere today. It takes local machine learning models on our devices and creates a more powerful global model by learning from our combined data, which is then used by our devices to improve. But if attackers access this global model, or indeed interactions between local and global models, they can extract sensitive personal information and compromise our privacy.
We propose using trusted execution environments or TEs to secure these models and interactions. TEs can't be accessed by the rest of the device, so machine learning models computed inside them don't leak any data, and interactions between TEs in different devices are encrypted. The approach is more computation and time efficient compared to other privacy preserving methods for federated learning.
While this is a natural approach, no one's done it yet.
Our paper provides a detailed outline of how to use federated learning with TEs. Thank you.
We will show you how we reveal malware obfuscation by analyzing electromagnetic emanation. Our work took malware samples from the real-world scenarios and analyzed EM traces which emanated from the IoT device, and therefore it involves no change to the target system. We complement different malware variants from DDoS, ransomware, and kernel rootkits. We apply state-of-the-art packers and obfuscators to understand if these techniques could hinder side channel. We put together a number of scenarios. Each of which represent a real-world malware classification by type and family, virtualization and packer discovery, and etc. Our approach consists multiple classification models using neural network and machine learning models. We are able to predict types classification with 99.89% accuracy in our test. We believe it's particularly useful for malware analysts. Please do not hesitate to contact us if you have any questions.
Hi, my name is Luis Klarman from Arizona State University, and I would like to present our recent project focused on mobile augmented reality, a very attractive technology that is quickly becoming a major trend. Recently, serious issues regarding this technology have emerged. For instance, thieves have abused it to lure gamers to insecure places to assault and rob them. To solve this, we developed a space mediator, a security framework that regulates how digital objects, which are core to augmented reality, are displayed inside physical spaces, giving users the opportunity to control who they want to interact with. So far, we have successfully conducted a preliminary evaluation and are actively working on a user study to further evaluate our approach. I hope you can save some time to stop by our poster stand and learn more about our project. Thank you very much.
Personal Data Management Systems, or PDMSs, enable users to assemble their data under their control. Instead of transmitting all data to a remote party for computation, PDMSs aim to provide a rich ecosystem while preserving users' privacy due to local data processing. Designing such a PDMS is, however, challenging since two conflicting objectives have to be filled: security and extensiveness. PDMSs must prevent users' data from being leaked while allowing extensive computations to be run by entrusted code. In this context, is there any way to preserve users' privacy using untrusted programs? In this poster, we introduce first a secure PDMS architecture designed to handle rich data computations. Then, we address the important problem of reducing information leakage in legitimate query results computed by an untrusted code.
The aim of the COLTRANE project is to look at cybersecurity as a collaborative activity, which basically recognises that all stakeholders have a role in it. So within an organisation, it's not just something for the technical team. All parties need to be able to relate to cybersecurity and understand it together. With this in mind, the project's reflecting on the relevance and coherence of cybersecurity education across different domains and organisation and national borders. We're looking at how cybersecurity education is currently provided and how this feels from the perspective of the educators and learners involved. Over the lifetime of the 3-year project, which is now completing its first year, we're producing a methodology for designing collaborative cybersecurity education, as well as an associated toolkit for teachers, and leading to a repository of materials that can be utilised. Our hope is that the result will support more widespread provision of collaborative interdisciplinary cybersecurity education, which will in turn ensure that graduates be well placed to support the needs of organisations in practice.
Hi, I'm Erik Daniel. I'm a PhD student at the TU Berlin in the group of Professor George. I want to present our concept concerning blockchains. In general, blockchains provide a distributed, Byzantine fault-tolerant, immutable and ordered block. One of these properties, the immutability, prevents some use cases for blockchains, especially anything concerning personal data. What we want to achieve with our concept is a certain degree of mutability. We adjust the structure of the chain, changing it into something like a skip chain, with the goal to make the deletion of certain blocks in the middle possible. Of course, the deletion of information, while desired, must follow some rules. To see how we want to solve some of those problems, or if you are interested in more details concerning possible use cases or the deletion process, see you at the poster.
Hi there, I'm Jo van Bulk from the DISNet research group at KU Leuven, and together with our colleagues from Birmingham, we have been looking into how to attack enclave software. This work was previously presented at the AXAC 2020 conference, where we won a distinguished paper award, and that's why we are now also invited to present a poster here at EuroS&P. So you're probably wondering, what are enclaves? Well, the easiest is to think of them as sort of super secure fortresses inside the processor. And since you're all security researchers, the real question is, how do you attack a fortress? History tells us the easiest is to aim for the gate, right? So that's what we did. We attacked enclaves through the I/O interface using only floating point instructions. We show that this attack works on a variety of runtimes, including for Intel SGX and more recently also RISC-V Keystone for a variety of applications, including neural network processing and rendering. Sounds cool? Come talk to us to learn more.
Hello everyone, I'm Munir Al-Gharabawi, and it's my pleasure to present our work Betrayed by the Guardian, Security and Privacy Risks of Parental Control Solutions. Parental control solutions are widely used to help digital parenting and protect children. In essence, these solutions work by intercepting network traffic originating from the children's devices. However, they can introduce serious security and privacy risks to children and parents due to their elevated privileges and access to a significant amount of privacy-sensitive data. These solutions are available across a variety of platforms, including desktop apps, mobile apps, browser extensions, and network routers. Therefore, we developed an experimental framework for analyzing security and privacy issues in parental control solutions. We used it to conduct the first comprehensive study of parental control solutions across multiple platforms, in which we identified 172 vulnerabilities across 54 different solutions. If you would like to know more about our findings, please join us for the poster session.
Hi, so this post is about the story of how we break the Bitstream encryption engine using the Bitstream encryption engine. So basically we found a vulnerability against the Xilinx 7 series FPGAs, which enables us to decrypt and manipulate its content. FPGAs in general are super cool devices, used in every industry because of their reconfigurable nature. Basically they are reconfigurable ICs, and this reconfiguration is done by loading a so-called bitstream. And here's the problem. If an attacker has access to that bitstream, they can steal all the valuable IP inside or even insert hardware trojans. So the vendors invented the Bitstream encryption engine, which we fully break on the Xilinx 7 series FPGAs, also known as the Starbleed attack. In general, we trick the FPGA into diverting decrypted content to a public readable register. And of course, we look on possible countermeasures and more general defense mechanisms. So I hope to have an inspiring discussion with you.
Hi, I'm Shravan from UC San Diego. I'll be presenting our work on retrofitting fine-grained isolation or sandboxing in the Firefox browser at the EuroS&P 2021 poster session. Browsers are complicated applications that support a rich set of features and media with the help of third-party libraries. Unfortunately, a bug in these libraries could potentially compromise the security of the entire browser, something that occurs frequently in practice. To address this, we built RLBox, a framework that allows easy deployment of in-process sandboxes to isolate untrusted libraries from applications with low overheads. At this time, RLBox has been deployed by the Firefox browser for over a year for millions of its users. Please stop by the poster session, where I'll be talking more about how RLBox works and its current use in practice. Thank you.